Hi, welcome to this video. In this video I'm going to tell you something about the project that I did, which I call Just Another PIC Programmer, or JAPP, which is programmed with the Just Another Programming Language, or YAL, which is a programming language for PIC microcontrollers. So what will be the contents of this video? First, why I created this project. Then the features of this Just Another PIC Programmer, the protocol that I'm using to send commands and data, the schematic diagram of this PIC programmer, and a printed circuit board that I created for this project. Then a typical setup on how you use the PIC programmer with a PIC that you want to program. Then I will explain what the standard programming sequence is, something about supporting tools which are available to make life easier, of course a demonstration video to see the PIC programmer in action, and at the end of this video you can find some references. So why did I create this project? Microchips has a software package which is called MPLAB-X, but the PIC3 is no longer supported after version 6.20. And for some time newer PICs were not supported by the PIC3 at all. So it was time for a low-cost, open-source, do-it-yourself PIC programmer which is able to support new PICs to program. A user manual on how to use this device will be available. It's open source and you can find the link to in the reference section of this presentation. So what are the features of this PIC programmer? It's connected to a USB port, but it behaves like a COM port, so you can send commands and data as ASCII characters. There's a micro USB-B connection to connect the PIC programmer to the USB port. But there's also an additional serial connection, which is used for debugging, but also you can give commands manually. And what are the main functions? First you have to load the PIC programming info, which is needed for the PIC programmer to program the target device. You can also load the hex file into the programmer, and then you can perform certain operations like blank checking device, erasing the device, programming it and verifying it. The PIC programmer supports both low voltage programming and high voltage programming, and the target programming voltage can be set to 3.3 volts or to 5 volts. So something about the protocol. Normally the syntax of the protocol, it starts with an exclamation mark, a command and then the data, followed by carries return line feed. And command and data are given in an ASCII format, and spaces in the data are ignored. And command and data are case insensitive. After sending a command, the PIC programmer will send a response. It will not send any data back. A 0 means, an ASCII 0 means that the command was executed successfully. And other responses use letters of the alphabet. So it starts from A and it ends at Q. And more details of this protocol and the error responses can be found in the user manual. So the schematic diagram, it looks as follows. It consists of two parts. This first part is the microcontroller, which is on the PIC programmer itself, and on the left side you see a memory, and this memory holds the downloaded hex file. At the bottom right you can see a block which is called the charge pump, and that's on the next one. And the charge pump is used for generating the high voltage programming signal. I made a printed circuit board for this programmer using standard components. And if you normally use the programmer, it looks like this, which is in fact the same as using a PIC3 and connecting into your target system, and the connections are the same as the PIC3, so they're interchangeable. So what does a standard programming sequence look like? First you have to load the PIC programming info so that the programmer knows the programming parameters for the PIC it needs to program. Then you can erase the device, load the hex file into the PIC programmer and program the device. And if there's EEPROM data in the hex file, it will also be programmed. And the last step is to verify the device. So there are some supporting tools for this programmer. There is a Python script called PIC Programmer.py, and it performs a standard programming sequence as I just explained. And you can provide the PIC number and the hex file as a parameter. It uses a default COM port, but you can overrule this by passing the COM port as an extra parameter. Then there's a Python file called JAPP.py, and it offers some basic functions to ease personal programming if you want to make your own script. And there's a file which has a very nice name like PIC class info.py, and that file contains all the PIC programming parameters of all the PICs. So the following will show the demonstration of this programmer in action. So what you will see, I will program a PIC using the Python script PICprogramming.py. And I'm programming a blink alert program that also contains some EEPROM data. And then after this programming I will do some manual actions, because I've also connected the serial interface, so I can also provide commands manually. I will erase and blank check the EEPROM, I will verify the device, and of course the EEPROM is also verified. Then I will also erase and blank check the PIC and reprogram the PIC because the file is downloaded into the PIC programmer. So what you see here is the PIC programmer connected to a target system on the breadboard, which is a microcontroller that has one LED connected to one of the pins. And what we're going to do, I'm going to use the PICprogrammer.py program to download a hex file into the programmer, which is a blink LED program including some EEPROM data, and then I will program the target system. For this demonstration I have also connected the serial interface so that I can send some commands manually using the terminal emulator program on the bottom right of the screen. So first let's start by starting the Python PICprogrammer.py program. So I'm passing as parameter the PIC that I'm going to program, then the hex file which contains a blink alert program where the LED is connected to port A0 and there is some EEPROM data in it. And I'm using COM8, which is different than the default. So let's see what happens. This is a little bit a slow PC, so it will take some time before, let's say, the serial port is initialized. But as you can see now, what has been done is first the data was sent over, this is the PIC programmer info, then the device was erased, the hex file was loaded, the device was programmed, we did a device verification, and we enabled the target VDD. And as you can see on the camera, the LED is now blinking. And on this terminal, the extra serial connection, I can also, let's say, type some commands. For example, I can do a verification of the device. And the response is OK, which means that the downloaded hex file in the PIC programmer is the same as the target system. As you can see, it disables the target voltage, so I can enable target VDD again, and then we can see it blinking. I can do a blank check of the device, and it says H, which means the device is not empty. I can also do a blank check of the EEPROM, and it gives the same results. I can erase the EEPROM, and I can do a blank check of the EEPROM again, and then it says OK. If I now enable target VDD again, the device is still blinking because that's the flash which is still there. So I can erase the flash, erase the device, and I can do a blank check of the device. If I now enable the target VDD, you see that the LED is not blinking because I erased the whole PIC. But I can program it again because the file is downloaded into the PIC programmer. And if I then enable the target VDD again, it's blinking. If I now erase the EEPROM, for example, and I will do a verification of the device, it says, hey, there's a mismatch, and that's correct because the EEPROM is different from what the data that has been downloaded. So let's erase the device. If I do a verification again, it will say it's not correct, which is correct that it's not correct. So That's about it. If you want to know more about this project, you can find it on my personal GitHub account. And if you want to know more about YAL and the YAL programming language, you can visit the YAL website. If you have questions on how to use YAL, there is a very good YAL tutorial. And you can also post your questions on the YAList Google group. If you find bugs in libraries or a specific request, you can post them in the YALib Google group. And all the YAL sources, including the sources for the compiler, can also be found on GitHub. I hope you liked this video, and thanks for watching.